This lecture video will describe different types of loads. Dead loads do not change over the life of the structure. An example is this tunnel, since it's holding the load of the mountain above it. Live loads change over the life of a structure, which means it is constantly changing. An example is the Golden Gate Bridge, since it is holding the loads of the vehicles and people on the bridge. Body forces are forces that arise inside a body. An example is the human body that naturally creates a gravitational force. External loads are when the load is transferred from outside the body. An example is the Shanghai Tower that is withstanding loads by the wind. Static loads are loads that do not change with time, typically within a period of a second or less. An example of this is a snowed-on roof. The roof is holding the loads created by the weight of the snow. Dynamic loads are loads that change with time, typically within a period of a second or less. An example is a teetering building in Taiwan that is falling due to an earthquake, since the load is changing within a period of a second or less. Point or concentrated loads are highly focused loads. An example is the hemeroscopium house, as this point here exerts a point load onto the horizontal beam. It's a point load because the weight of that load is focused on a specific point. Distributed loads are loads spread over a finite area. An example is the Baishu Sabor Dam, as it experiences loads on its walls by the water spread over a finite area. Uniformly distributed loads, also known as UDLs, are evenly distributed loads. An example is how the water in the pool creates a vertical load on the pool floor, which is distributed evenly. Moments, torque, or couples are applied at a force and distance. It determines whether a moment is created. An example is the Dubai Twin Tower, as it has a part of a structure extending out. The loads on the horizontal piece of the structure will cause a moment. This chart is a summary of all the loads that was just described. Now let's work on this example together. Use the terms defined previously to describe the various loads that act on the building shown to the right. Feel free to pause the video if you would like to consider the components on your own. Let's start by examining the elevator motor. This motor is considered a live load, a static load, and a point load. The air conditioner is also considered a live load, a static load, and a point load. They are both considered a live, static, and point load since they do not change over the life of the structure, they are not changing within a period of a second or less, and they apply the loads at a specific point, respectively. The construction materials are considered a dead load and a static load because the materials are not moving and are not changing with time, respectively. The aerobic class is considered a live load and a dynamic load because the people in the class are constantly moving and changing according to time, respectively. The wind is considered an external load, a dynamic load, and a distributed load. The wind is applied evenly from outside the building and is constantly changing with time. The soil pressure is considered a dead load, an external load, and a distributed load since it does not change over the life of the structure, it's not created by body forces, and the load changes along the depth of the soil for the distributed load, respectively.